we now have Jibby, Ayo-Ani, who actually is going to talk about what is the cloud, how you get resiliency, and how do you make the cloud more effective, because we just learned that cloud doesn't solve everything, but I think we're going to learn something in this presentation that we could use to use the cloud more efficiently. So let me just introduce Jibby. Jibby actually works she's a DevOps engineer for Welkin Health, and they're a healthcare startup in Silicon Valley, and I believe you just went from Series A to Series B?
Yep.
Very exciting. So yes, they're starting up very fast. So Jibby works across multiple industries, and actually something very interesting in your bio, you stop bad people. You use technology to stop bad people?
Yeah, I'll be talking about that.
Okay, so let's tune in and give Jibby a welcome.
Thank you very much. Well, hello everyone again. My name is Jibby Ayo-Ani, and I am a lead DevOps engineer and an Amazon Web Services certified solutions architect. I'm currently working out of a 50-person health tech startup in San Francisco, California called Welkin Health. Let me give you a little bit of background of who I am and some work I've done and a story to get to know me. I was born in Washington, D.C. A few random facts, a few random facts. I am a lifelong student of music. I sing in a band at my church. I love to hike, and I was on a traveling jump rope team as a child. I've lived in Nigeria, England, the Marshall Islands, and many places in the United States. Now, most people I've met have never actually heard of the Marshall Islands, let alone can point it out on a map. Well, there it is, smack dab in the middle of the South Pacific between Hawaii and Australia. I had the pleasure of being able to live in this developing country consulting for the Marshallese government. Why? Well, have you ever seen those movies or TV shows where the bad guys are laundering money through some offshore bank accounts? Well, this happens in real life. The Marshall Islands are one of those islands that people really launder money through or even finance terrorism, or did anyways. As a developing country, the islands didn't have the technical means to build out a solution to ward off such criminal intent. The Government Banking Commission, the lead agency for anti-money laundering in the Marshall Islands, received financial information from the local banks turned in by paper, and it was inputted into a single Excel spreadsheet. There were more than 15 years of backlogged paper documentation that needed to be manually inputted. No wonder it was so hard to catch the bad guys. Well, I was a consultant for the government of the Marshall Islands to create a process for submitting these documents electronically and storing the data in a database, allowing for more thorough analysis to track patterns in suspect activity. Currently, it assists the country in combating money laundering and terrorist financing. So it feels pretty good to be a part of something so impacting. I've always wanted to do something that impacted the world positively and leave the world a little better than when I arrived. And that's how I ended up at a small health tech startup, Welkin Health. Welkin is a tool for adding value to the healthcare system by making it more efficient. We build a better way for patients and health professionals to communicate and coordinate. One shorthand way of talking about Welkin software is that we're building a batteries-included CRM for healthcare. Care delivery companies need CRM software to make their health programs run efficiently, and we hope to make the world a healthier place by empowering health organizations to deliver patient-centered care. At Welkin, I get to create a product that facilitates long-term sustainable medical care for patients. So now that you know a little bit about me and my professional background, I wanted to pivot for a moment and share something really important to me and core to my identity: my love for dogs. Now, I know this is relevant, I promise. I've been quite obsessed with dogs for my whole life, but there was only one problem. My mother was irrationally afraid of dogs, but after years of begging and pleading and nagging for a dog, the eyes of this sweet little adorable pup changed hearts that day. We took our little Riley home, and as every new dog owner knows, we captured every one of her moments on camera. And one day after coming in from the rain, she did something quite interesting, and the camera came out. see if I can get this. Like every good dog mom, I of course put it on Instagram, calling on other dog parents to see if their dog was as quirky as mine. After opening up my phone a couple hours later, it had blown up online. Hundreds of people had been tagged, thousands of likes, and I was in shock. Hours after that, a huge media company had reposted her video, and 21 million views later, we had about 20 requests in our inbox from digital media companies asking to represent Riley and her video. And that is the day that we became a dual income household. Thank you. Well, just for kicks, has person in this room seen this video before? Oh, yep, thank you, and thank you. You helped us pay rent. So why did I tell you that story? At first, it might seem like a lighthearted scheme to get you to like me because I have an adorable dog, yes. And really, what that story is about is what that a dog with a couple hundred followers on Instagram, at Riley_the Boston Terrier, if you're interested, it could blow up in a matter of hours and become known to millions around the world. That a platform like Instagram and Facebook can house the compute power to deliver content to millions of people across the world without delay. Well, welcome to the cloud. The ominous cloud that we've all been migrating over to in the last 10 plus years as the industry standard calls for. We've seen the pushes from Google, Microsoft, Amazon, and companies alike. How to build your cloud strategy, accelerate your results, everything you need to build and scale. But when we're all buying into the hype and no one's doubting, we can get ourselves into trouble. Can I see a show of hands? How many of you interact with Amazon Web Services, AWS, the cloud service provider? Awesome. Now, with everyone with your hands down, if you think you aren't interacting with AWS, you're probably wrong. You just don't know it. Do you use Slack? Do you watch Netflix? Or do you shop on Amazon? Well, you're interacting with AWS. How big is AWS exactly, you ask? Well, it hosts over 140,000 websites. So a large portion of those 100,000 websites were affected in the great 2017 outage of AWS. And if we didn't learn from our mistakes, they were also affected in the great 2018 outage of AWS. If your Alexa suddenly went silent or your Slack channel stopped working, Amazon Web Services went down. On March 2nd, 2018, between 9:23 a.m. to 1:26 p.m., AWS data centers in Virginia suffered downtime, affecting customers all over the East Coast and the world. Slack, Medium, Imgur, SoundCloud, Quora, Mashable, BuzzFeed, I could go on. Thousands more sites you may need to access work or to avoid working were impacted. Cloud computing, yay! Now yes, cloud computing is the next big thing to bring us to a new level of content distribution in computing. But I argue that as we as an industry move towards cloud computing as a standard, to take the burden off managing our own data centers, the standard for security and reliability to our customers do not change. So what does it look like to continue to have high standards of security and reliability as we migrate to the cloud? Well, to explain how to get there, we first have to understand the cloud. And in a national survey, not even 10 years ago, most Americans were confused by cloud computing. Here are some fun cloud facts for you. Did you know that 51% of people believed stormy weather had an effect on cloud computing? 29% of people thought the cloud had something to do with the weather. 95% of people have used the cloud but don't know it. Now, although these facts are pretty hilarious, it also goes to show how ubiquitous the cloud actually is and how little people really knew about it. But we've come a long way. So what is the cloud? Well, what if I told you there is no cloud, it's just someone else's computer? Shocking, I know. Now, hold this thought. We'll come back to this in a second. When I was working at Capital One, what's in your wallet, I kept hearing that we're migrating to the cloud. We're from our on-site data centers, that it would save us cost and make us more secure. So what did that actually mean? Well, not how it sounded. Imagine this, we're a little startup with a limited budget hosting its own data centers, paying for the cost of these physical data centers, building costs, power, security guards, and the expertise to main it all. Of course, people are the most expensive asset. Money that we don't have. And not only are we paying for the power and storage that we currently use, we're also paying for the potential of power and storage that we anticipate we will need in the future, because we will inevitably go viral like my dog and need to handle the traffic of our millions of users. And since it can take weeks to acquire and rack new equipment to handle such spikes, we must provision for them in advance. And heaven forbid we overestimate and pay for all of that extra unused space on top, or underestimate and risk creating a poor customer experience when the demand on the application exceeds its capacity. While the cost of over-provisioning is easily measured, the cost of under-provisioning is more difficult to measure, yet potentially equally serious. Not only do rejected users generate zero revenue, they may never come back. So, we're this little startup juggling all of these costs, then AWS swoops in and says they can take care of all of the hassle, the costs of physical and online security, power, and take away the biggest financial burden of the expertise to maintain these servers. All we have to do is pay for simply what we use. And to throw us a bone, they guarantee that they can handle the spike in usage when we surely and inevitably go viral, as every startup does. All through the cloud. So I ask again with this context, what is cloud computing? Well, I bring us back to this concept of using someone else's computer. Instead of taking the burden of housing networks, servers, storage for myself as a company, I hand that burden over to these cloud service providers like AWS. Okay, so we have our calibrated answer to the nebulous cloud computing question, not to be confused with nebulous clouds, is for me, as a developer, a cost-effective and convenient access to resources, allowing me to rapidly serve my customer. So cloud computing is essentially just me renting space on physical servers that Amazon maintains in a data center somewhere that I don't even know about. So let's take a real-life example to really drive home this definition. The Super Bowl is undoubtedly the biggest American television event we have. It's an incredible marketing opportunity where companies will invest millions to get a 30 to 90-second commercial slot. About 100 million people per year will tune in on this Super Bowl day to watch the best commercials of the year. Some of us have never actually watched football during the season until this big game. But one commercial in particular caught the eyes of Super Bowl fans during the 52nd NFL conference in 2017. They showed a 90-second commercial of what it might look like to be a refugee crossing the borders, and it ends with, see the conclusion at journey84.com, cliffhanging. As you can imagine, within 1 minute of the commercial's airing, the website received more than 300,000 hits, enough to slow down the load time and display a services unavailable message to visitors. 84 Lumber, the 61-year-old lumber company that created this commercial, said the site was only able to serve 150,000 requests per minute and that the issue took 10 minutes to resolve. During that timeline, the company redirected viewers to YouTube as the 84 Lumber site restored. After 1 hour, the site had received more than 6 million requests to load, an expensive mistake for the $15 million the company paid to have this 90-second slot by failing to prepare the hosting foundation of their website, though quickly resolving the issue. Another more relevant example, as we all can remember, I'm sure, is the long-awaited opening of Obamacare. Americans began shopping online for health insurance on the new state exchanges created by the Affordable Care Act. There were major problems all over the world with accessing the site. Websites were slowed or crashed altogether, leaving a lot of folks angry and frustrated. The millions of people flooding the system on healthcare.gov caused the website to briefly break under the strain, going from apply now to please wait to please try again later. Administration officials said the site was overwhelmed by 2.8 million visitors, a number they never expected. They expected a slow ramp and yet received an overwhelming response. A simple answer to solutions like these is requiring a web hosting solution that can stretch its capacity to accommodate a sudden spike in traffic. like taking advantage of AWS's auto-scaling group solution to increase or decrease the number of running instances or servers to dynamically meet changing conditions. When the correct policies are in effect, the auto-scaling group detects these slight changes and adjusts the desired capacity of the group to launch or terminate instances as needed. Now that we see these use cases for the need of cloud-based platform, we can use these examples for the purpose of this scenario to say, okay, we agree of our definition on cloud computing. We agree we'll buy into the hype, we'll get on the cloud. We don't want our service going down. We don't want to get the dreaded 503 errors. We'll get on the cloud. So what now? We've handed over all of this responsibility to the all-knowing Amazon Web Services. Well, remember a few minutes ago when we saw what it looked like to hand all that responsibility over to AWS? Yeah, you'd forgotten, hadn't you? Well, I implore you to remember that as the industry moves towards cloud computing as a standard, the standard for security and reliability to our customers do not change. So what does that mean for you? With all of these examples, I want to stress the importance of developing in the cloud and how this is becoming the industry standard, but to also build out your knowledge in the cloud to be able to leverage to your companies that you can not only provide a cloud solution, but a better cloud solution. What does that look like? I want to highlight a key concept of disaster recovery. Disaster recovery is one of the many infrastructure solutions to higher reliability and resiliency in the cloud, and one in which I've worked with many teams to build out a fault-tolerant system. Now, when I say fault-tolerant system, that is something to constantly strive for, yet I have a news flash for you. Failure is not an option, it's a fact. Failure is inevitable. It allows us to grow, recognizing that there's no such thing as a perfect system. Even if there were, there are always external influences that impede the integrity of our perfect system. For instance, remember when I shared those figures on cloud fun facts and we all laughed at those 51% of people who believed stormy weather had an effect on cloud computing? Well, they're not wrong. The weather is actually an important factor when it comes to thinking about cloud computing. One of the first things you do when you open an AWS console is choose what region you want to be in. You're probably familiar with AWS regions, but let me give you a refresher. A region is a geographic area where AWS has data centers. Each region has 2 or more availability zones, which are independent data centers that are located close to each other. Availability zones are used for the redundancy and also for data replication. For services such as EC2, AWS Elastic Compute Cloud Solution for hosting servers, you can choose which availability zone you want your instances to be launched in. As of today, there are 18 public regions across the world, but not all regions are created equally. They vary in cost, performance, and number of availability zones. Not only that, but they differ in the natural disasters based on that region of the world. With every region comes different environmental factors that you also need to take into account when building out your cloud solution with fault tolerance. In California, we have earthquakes. In Northern Virginia, tropical storms and hurricanes. Remember when those AWS data centers in Virginia went down? Well, they isolated the solution to connectivity problems at the data centers. A network facility lost power after the Washington, D.C. area experienced extremely high wind gusts. I repeat, failure is inevitable. As a result, we have to plan for failure at every level and design a system that gracefully handles it when it does occur. During those AWS failures, we received so much backlash. Being a financial institution at Capital One, we were able to use this incident to push our standards for higher standards for every single customer-facing application to have a disaster recovery plan. To build out your infrastructure with a disaster recovery plan, you need to build by replicating data across regions. You can see here how this architecture is replicated across 2 regions. We also have these elastic load balancers, or ELBs. Load balancers automatically distribute incoming application traffic across multiple targets, such as Amazon's EC2 instances, and can handle the varying load of your application traffic. We have this logical group of servers processing our requests, the instances within the auto-scaling group, yet we need to know which instances at any point in time are actually going to process a specific request. We also need to make sure one instance isn't taking all of the requests and there is an equal balance amongst all of the healthy instances. Well, imagine this. You're in a foreign country, your wallet gets stolen, and you need to call your credit card company to cancel your card. You find the customer support number, and you're prompted to press 1 to check your balance, 2 for your lost and stolen card. You press 2, and after what feels like the 1,000th hour of being on hold, you're speaking to a customer service rep to cancel your card and get a replacement. Now, the phone system that did the work of finding an available rep to answer your call serves a nearly identical function as a load balancer. The credit card company has to keep track of how many representatives are able to receive a call and which reps are currently taking calls. It needs to be able to notice when a rep is on a lunch break or not picking up, so it can redirect calls before the caller gets annoyed and hangs up. It needs to use the right algorithm to make sure that calls get answered as quickly as possible without burning out every rep in the call center. A load balancer, likewise, needs to keep track of how many servers are available to receive incoming requests by periodic health checks. It needs to be able to notice when a server isn't responding to a connection, so it can mark the unresponsive server as unhealthy and pick another server before the request times out. It also needs to pick an efficient algorithm to make sure the servers are handling optimal number of requests. The basic idea is the same in both cases. One destination that the world uses to reach the resource, balance between many back-end resources that can handle the incoming load. So we go back to our example, understanding the role of load balancers, and you can see as well Amazon's Route 53 managed domain name system is where traffic is routed through. Essentially, Route 53 connects user requests to infrastructure running in AWS, the EC2 servers via the load balancers. You can configure health checks for your resources, and Route 53 responds to DNS queries or user requests using the healthy resources. For example, suppose your website, RileyTheBostonTerrier.com, is hosted on 6 servers, 3 in each 2 data centers around the world, as we see here. You can configure Route 53 to check the health of those servers and to respond to DNS queries for RileyTheBostonTerrier.com using the only servers that are currently healthy. If a disaster, in fact, does happen and one of the AWS data centers goes down, it should have little to no effect on your customer. Route 53 can detect that it's unhealthy and stop including it when responding to DNS queries. Now, this can be an expensive solution, essentially doubling the costs of your infrastructure by building out this strategy. This is considered an active-active failover solution when you want all of your app instances in all regions to be available simultaneously. This is for applications that cannot afford to lose connectivity, like a health tech company managing ongoing patients or a bank with customers who need access to their money at all times. Because one of the teams that I worked with on Capital One managed an internal tool, we were on a lower priority implementation of disaster recovery and active standby approach, where we built out the capability to deploy to another region within a recovery time of 1 hour instead of 0 minutes as the active-active approach calls for. This allowed for us to have the skeleton built out in our deployment scripts, so in the event of a regional failure or data center going down, we have the capability to spin up in a different working region within 1 hour. These are just a few options of implementing a disaster recovery plan and what I've seen firsthand from failures and recoveries. Now, I did say failure is a fact, but one thing I always learn is that failure doesn't have to be my own for me to learn from it. So learn from all that I've gone through and let this talk empower you to push your infrastructure in the cloud to higher standards. When we look at the cloud, there are always strategies that we can build upon to improve our security and reliability, and that's really what I and my dog wanted to advocate to you today. Thank you very much, and thank you for your time.
I know, right? Awesome. That was awesome. Is it okay if we do a couple questions?
Yeah,
You cool with that? All right, any questions from folks? Not a one? Not a single? Oh, right here.
Is there any great examples of a system that didn't go down because it could handle the number of requests that came in because
Yeah, absolutely. I
Repeat
mean,
the question.
so the question was, is there any solution that didn't go down where there was a regional failure? I mean, when you thought about the 2017 downtime, like there were tons of applications that were still up. I think like Twitter was still up and people were still able to share this information. But yeah, there are obviously like solutions that have been in place to be able to have these active failovers with zero downtime. So there were a lot of applications and websites that were still up within this downtime of AWS.
In fact, one of the big articles that was written at the time of the 2017 outage was about using Kubernetes, and how someone had written an application using Kubernetes to fail over, and we had them at DevNation Federal speaking in 2017. So there you go. Other questions?